Today we're going to go over the year function. The year function is a part of a group of functions that are responsible for returning parts of date and time. I'm going to give you a typical little cute definition, and then I'm going to follow it up with a cute example. But afterwards, we will dive into how to really use the year function to deliver some insight. And that, my friend, is what you're going to get from me today.
Today, Brandon from the Data Analytics Training Centre will be coaching you. He is a man that by day moonlights as a data analytics personal trainer and business intelligence freelancer. Here's 3 of the top least interesting things about the man.
1.
He lives vicariously through himself.
2.
In museums, he is allowed to touch the art.
3.
He once ran a marathon because it was on his way. He's a man with balls of steel. Now let's go. Don't keep him waiting.
The year function is one of the most practical functions of all the date and time functions. It's very versatile. It's simple, and it only requires one parameter that takes a specified date and returns the year number portion of that date. Now, you can either explicitly specify the date for the parameter, or you can specify a DateTime function like getDate. What getDate is going to do is that getDate will run at code runtime and pass the current date to the year function. As both of these queries that you see here share the same date, they also share the same year number, as you can see being reflected here. Another way to really take advantage of the year function is to deliver greater insight by combining it with other functions. If we pair the date add and the year function, we can calculate fiscal year. For those that are unfamiliar with the differences between calendar and fiscal year, many businesses use a fiscal year when their primary operating season doesn't fall neatly within a single calendar year. It's also used often for tax purposes. So let's say that the beginning of our fiscal year extends 6 months into any regular calendar year. And we would like to determine the fiscal year for all the orders across our business for tax reporting purposes. That means we will be taking order date and based on that date, calculating the fiscal year to find out what fiscal year that order date was a part of. With the date add function, we would start by determining what is the date our order dates fall in 6 months from their calendar order date. We will add 6 months because, again, our months for our fiscal year start 6 months into the calendar year. So using date add, we can add 6 months to our order date and get the fiscal date back, extracting the year portion to identify the fiscal year that that order date is a part of. So another way to really use the year function is by using it with a combination of other functions. Again, for instance, to identify the median revenue by year. For those who are unfamiliar with the median, it's simply a numeric value that separates a higher half of a sample, a population, or a probability distribution from the lower half. The median is generally useful to determine the central tendency of data. Statisticians would go further and say the median determines the central tendency of data distributions that are not normal, which is to say that it's useful for data that's skewed. Okay. Average or mean also measures the tendency of data, the central tendency, but it's mostly applicable for data with a normal distribution, data that's not influenced one way or another by skewed data. A normal distribution data set tends to have no bias left or right. So let's take a look at our example. We need to solve a problem that seeks to understand what is typical about our revenue across a number of years. Let's look at a soft example before we get into our demo, but let's say that the total revenue for a company is $90 million. We want to understand what is typical for our company year by year, over 9 years. The average tells us that our company makes $10 million on average. However, if we look at the numbers, most of our values are less than $10 million. $10 million does not really represent what is really a typical revenue year for our business. This results because our data is skewed due to the bias of outliers. The median does a better job of identifying what's typical in a case such as this. The median of 5 million is a better reflection of a typical yearly revenue for our company. Here you can see the years potentially that are worse than typical and the years that are better than typical. Let's calculate a median. We will be using the percentile_disk analytic function and the year function. So the percentage_disk analytic function computes a specific percentile for a set of data values. When we specify the percentile_disk .5 within the parentheses for this function, it's going to calculate for us the 50th percentile, which just happens to be the median for a set of data values. The within group clause identifies the set of data values we would like to determine the median for. And in our case, we want the median for the values along the subtotal column, since for our data set, it represents the revenue for our business. The over clause identifies how we want the result set to be applied or partitioned out. And we want to see the median revenue, again, shown by subtotals, over a range of years that we have orders for. The year function is used to determine the order date years that we want to partition by. And that is how this analytic function, along with the year function, is working to identify our median revenue.